Hi guys, welcome back to another Gen Code lesson, and today we are going to be discussing data types in Python. So before we jump into this presentation, let's just give a little recap on what we did in the previous two sessions. So we talked a little bit about the history of Python, we said how Python came to be, and we also compared it to Python to other programming languages. I also gave you a little rundown of what we're going to be doing throughout this course, and showed you a little demo on what could be the outcome once we finish this on an IDE. If you haven't checked the other video out, I also showed how to set up the IDE and the environment. So if you haven't seen that, please go back and rewatch that video to set up the PyCharm environment. In this course, we are going to be using PyCharm as our IDE. So just so you guys are aware, we did cover that in the previous video, so if you haven't seen it, just hop over there. But anyway, today we're just going to be discussing data types in Python. So without further ado, let's just jump right into the presentation. So the big question is, what are data types, right? What are data types in programming? So data types are basically attributes that tell the compiler how the program intends to use that data as. So in Python, we have five main data types. We have strings, we have numeric, we have tuples, lists, and dictionaries. And in the numeric, we have two categories they could fall into. They could fall as integers or floats. And we'll discuss more about the difference between the two in the future slides. So like I said, in Python there are five main data types, right? And I listed right here: strings, integers, lists, dictionaries, tuples. So these are the main data types we're going to be focusing on throughout this course, and these are the main data types that we'll be using throughout our coding in PyCharm. So let's go run one by one and break down each of these data types. So the first data type is a string. What is a string? A string is a sequence. It's a sequence, right? Each item in a string has a defined position. So each of the letters in a string are defined as a position, right? They have positions in each letter is in a position. So we can refer each character within the string by its defined position, or in programming we like to call indexes. So each letter is an index. So for instance, H will be 0, E will be 1, L will be 2, and so forth. And with indexing, I will always say we always start with 0. So indexing always starts with 0. So you always, with anything in the first letter in a string, we always start at 0. And we work our way up from there. Strings are immutable, meaning when we define a string, like the one we see right here, hello world, we cannot add a letter to that, or we cannot remove letters from that, because they're immutable. Once they are created, they cannot be changed. So for instance, let's see right here, we have an example, print s of 4. So what is s of 4? Well, s is equal to the string hello world, and we gotta go to the fourth index. So we count each letter, right, by indexes: 0, 1, 2, 3, 4. So this will print out O, and that's what we got. We got O in the console. Another example is we find S of 3. So S of 3 is L, and that's what we printed. And in the last one, it shows 1:3. And this time when you see something with a colon, we don't call that indexing, we call that slicing. And we'll discuss the difference between indexing and slicing and how they are different from each other. But if we want to print S of 1:3, that means we want to start, this is the starting position. So the starting position is E. We'll be starting at index 1. And we go up to index 3, but we do not count index 3. So what I like to do is just count each of the letters, count each letter by indexes. So we start at 1, so 1, 2, 3. So these are the 3 letters we picked up. But like I said, we don't count the ending index. So if it ends at 3, We only go up to 3, but not including 3. So at this point, this will just print index 1 and 2, which is EL, and that's what we got in the console. And like I said before, strings are immutable, so again, you cannot add or change anything once you define a string. So here's a little better example, and here's a better way to visualize what I mean by indexing a string. So what is an index? An index in programming is known as the reference or the position of a character in a string or a list. So like I said in the previous slide, indexing always starts with 0, not 1. So for instance, H will be 0, E will be 1, and we'll go forward from there. We could also count indexes in the negative direction. So we could start at 0 and work our way backwards. And when we go negative indexes, we start at -1. So O will be -1, L will be -2, and so forth. So indexing is the defined position. For example, let's look at the example right here. So S is equal to hello. SO1 will give us the character E, not H, right? Because remember, indexes always start at 0, so H will be actually at index 0. So index 1 will be actually E, and that's what we'll get E. Another thing I'd like to point out here is white spaces, right? White spaces always count as characters. So if you see a space, let's go to the previous slide again. If you see a space in between the two words, we count this as an index. So this will be index 4 at O, but this one is going to be index 5. The space counts as index 5, and the W counts as index 6. So always count white spaces as a character. So that will bring us to indexing. Let's go to the next slide. Alright, so we covered strings. Let's cover numeric data types. So right here, like I said before, we have 2 numeric data types in Python we use frequently. They are integers and floats. So what is the difference between an integer and a float? Well, integers are basically everyday whole numbers you see. And you probably see them in math class, at a grocery store, or anywhere. They're basically just whole numbers. And for example, like 2, 5, 10, 38, integers are whole numbers. In computer science, if we want an output to be a whole number, we use the int data type, meaning int standing for integers. Floats, on the other hand, are similar to integers, but they are not whole numbers. They contain decimal points. So for example, 2.4, 4.5, 0.0, those are all counted as floats. And again, if you want in computer science, if we want to use the float data type and we want to express an output that contains a decimal point. So we use the float data type if we want an output that contains a decimal point. So that's the main difference between an integer and a float. Integers are whole numbers, floats contain decimal points. So here are 2 more data types we want to discuss, and they are lists and tuples, and this is the big confusion where people get these 2 mixed up. There's a big difference between a list and a tuple. So lists are basically surrounded by square brackets, meaning if you see square brackets around the data type, it's basically counted as a list. And lists can be modified once created. So this is an exception from strings. Strings are immutable, but lists are mutable, meaning you could modify a list or add to a list or remove an item from the list once it's defined, because they are mutable data types. And some of the methods, again, that are associated with a list are .append, which means you want to add something to the list, or .remove, which means you want to delete something from a list. So by list, I mean, let's take a grocery list, for example, right? We have a list of bananas, orange, and apples. If I say, let me add something to a list, I want to add pears to it, I can always say list.append pears, and that will add pears to the list. But if I want to remove something, I have to say list.remove apples, and I could remove from the list. So with lists, you could always change and modify them. Tuples, on the other hand, you cannot modify them, and you will know they're tuples when they're expressed surrounded by parentheses. They're not surrounded by square brackets, they're surrounded by parentheses. And like strings, tuples cannot be modified once created. They are immutable data types. So once you define a tuple, you cannot modify it because it's immutable. Okay, so like in the beginning, we were discussing about indexing and slicing. Here's the main difference between indexing and slicing. Indexing returns one item as a string or a list, while slicing returns a new string as that could be associated with a list or a tuple. So for what I mean when indexing returns one item, I mean like let's say we have a list, right? We have a list that's equal to 0, 1, 2, 3, 4, 5. And I want to pick an index. I want to index this list. So let's say I want to pick the number 0, right? So I will say list of 0. And when I type that into the interpreter, Python will give me back 0 because at the 0th index, I have the number 0. But if I said list, if I want to slice it, this will not return one position. This will return multiple positions. So let's say I say list of 0, nothing at the end, right? This means I'm slicing the list from the 0th index all the way to the end. So at this point, I'll get 0, 1, 2, 3, 4, 5. I'll get the whole list when I slice. Compared to when I don't use the colon, I only get one position. So this is indexing, this is slicing. Another example would be list of 2. Well, at the second index, I have 2, right? So when I index list of 2, I'll get 2 back, one item. But if I say list of 2, 4, which is slicing, I'll start at the second index, which is 2. I'll go up to the 4th index, which is 4, but I won't include 4. So I only get back 2, 3, because I don't include the 4th index. I go up to the 4th, but not including the 4th. So I'll get 2, 3, multiple positions. So that's the one main difference between indexing and slicing a data type. When you use indexes that are outside a specific range, Python will throw back an indexed error. So let's say I have a list 6, right? Let's say I want to get the 6th index. Well, there is no 6th index here in the list, in this list, right? It goes only up to the 5th index. So at this point, I'll get an index error because the index is out of range. But with slicing, you will not get an error. Python will actually be able to handle that properly. So if I said list from 4 to 6, means start at the 4th index and go up to the 6th index, but not including the 6th index, I'll get 4 and 5, which is the 4th and 5th position. Also, if I said list of 4, 7, I'll have to go up to the 7th index, but not including it. So I'll get the 4th, 5th, and 6th index. But since there's no 6th index, you assume Python will throw back an error. But in this case, it will still give me back 4, 5 as the output, because with slicing, you will never get the error if it's out of range. If it's out of range, it will just give you back the rest of the list, or whatever the data type is. In indexing, we cannot change the length of a list, but in slicing, we can change the length. So for example, if I did a list of 3, I only get the one number back. I'll get 3 because that's the third position in the list. But if I slice this list 0, 1, 2, 3, 4, 5, and I said a list of 1, 3, so now I got only 2. I got a length of 2 in the list. I got 1, 2 compared to the 6. So I changed the length from 6 numbers in the list to only 2 numbers in the list. So that's what I mean. You could, with slicing, you could change the length of the list, but with indexing, you cannot change the length of a list. Right? So let's move on to the next slide. All right, dictionaries. Now this is a big one right here. Dictionaries are really crucial in Python, and this will help you with your capstone project when we get to that point. So dictionaries. So dictionaries is a set of key value pairs that are separated by a colon. So you could think of dictionaries like unique key and values, right? So let's take programming from a side, right? Let's not think about programming. Let's just look at a dictionary, right? So probably in English class, you have to look up a vocabulary word, right? It's a dictionary. And you look up each of the words. Each of the words have different meanings, right? The key, which is the word, and the definition, which is the value of that word. So you could kind of think of a dictionary as a vocabulary word, a word and its definition. That's all that is. Dictionaries are basically how it works in the English class. It works the same way in programming. So you could tell this is a dictionary because it'll be having key value pairs separated by a colon, but also you'll notice they have curly brackets surrounded. Like lists have square brackets, dictionaries have curly brackets. And here are some of the rules that we need to know when we create a dictionary in Python, right? A key can be any immutable data types such as strings and tuples. So meaning if a key can only be immutable types, you cannot use list as keys. So for instance, Alex, this will be valid for a key because it's a string, but you cannot put square brackets around this and make it a list. You cannot use mutable types as a key. That is a big no-no. But you could use mutable types for values, however, or immutable types for values. So you could use list as values, but you cannot use list as the key, which is this value. So you cannot use on the left side, but you could use on the right side, which is the value. And each key in a dictionary must be unique, meaning each key, whether it's Alex, you cannot have duplicate strings that are called Alex as keys. So this cannot be, Ben cannot change to Alex and be the same one. But however, if I change the letter, let's say I had Alex again, but instead of a capital A, I had a lowercase a and had it as a string, that would be unique because Python handles capital letters as unique. So what I mean by that is a capital A is not the same as a lowercase a. So these two are very different from each other. So that would be valid. And unlike the key, like I said, the value in the dictionary can be any immutable or mutable type. So list, you could use a list as a value, but you cannot use a list as a key. And remember, keys are always the left side. This is the key, colon, value. So this would be the key, colon, value. So Alex, right here, for example, Alex is the key. The value is 5. Ben is the key. The value is 10, and so forth. All right, so I think I covered a lot with diction. I covered a lot on data types today, but it was a little quick. So if you have any questions, comments, concerns, feel free to post your comments or concerns or questions in the email at gencode.us under ask more questions. If you need any help with, if there was nothing that was not clear or something, feel free to email and get your answered as quickly as possible. But let's take away some of the key takeaways from today's Gencode lesson on data types. So again, what are data types? Data types are attributes that tell the interpreter what the programmer intends to do with that specific data. And the big one is strings and tuples are immutable, while list is the only mutable data type that we discussed in today's lesson. Another key thing is errors, right? Indexing, when you index out of range, it will always throw an error, but slicing will never throw an error because with slicing, it knows how to handle. It knows how to handle out of range numbers. But indexing, you always get an index error if you were to go out of range when you index out of range. And again, finally, dictionaries, and you know they are dictionaries when they're surrounded by curly brackets, but you'll also, the big one, you'll also know that dictionaries when they contain a set of unique key value pairs. Like example right here, Alex, the key, colon, and then 5 as the value. So, and they're surrounded by curly brackets. This will be an example of a dictionary right here. You can see right there, that's a dictionary. So, like I said, if you guys have any comments, questions, concerns, feel free to email us and we'll get your questions answered as soon as we can. And again, if you need to look over, we'll have this video posted and you could take a look at it on your own because this will be recorded. But like I said, this is a big first step we're taking towards that capstone project. And we'll discuss, and data types are going to be huge. This is a huge thing in programming. So if any questions, comments, concerns, feel free to email us and we'll get your questions answered as soon as possible. But until then, I will see you guys on the next lesson and I hope you have a wonderful day.